Hello everyone! We'll be talking about different ways to find the volume of this cup.
We can use definite integrals to find the volume of three-dimensional solid revolution that results from revolving a two-dimensional region about a particular axis.
The methods we will use to find the volume of a cup include the disk method, the washer method, and the cross-section method.
Hi guys! Here's the graph for our cup. We divided the intervals into three parts. The intervals are 0 to 0.2 and 0.2 to 9.6 and 9.6 to 10.7. The black line, red line, and purple line are the outer volume, and the blue line and green lines are the inner volume. As you can see, the length of the cup is 11 cm, 2 cm, 7 cm, and 10 cm. Now moving on to the disk method. The disk method is a way to calculate the volume of the solid revolution by taking the sum of the cross-sectional areas of thickness of the solid. The basic formula looks like this. To get the volume inside the cup, I got the intervals between 0.2 to 9.6 and 9.6 to 10.7 and used the equation. And add them up, the total volume was 395,608.
If we suppose the generating region R is bounded by two functions, y equals fx on the top and y equals g of x on the bottom, the shape of the slice is a circle with a hole in it, just like a washer. The formula for the volume of a washer requires both an inner radius r1 and an outer radius r2, so we subtract the area of the inner circle from the area of the outer circle. The basic formula goes as follows. To find the volume of the space inside the cup, we have constructed different equations to graph the shape of our object on the very outside and on the inside, considering the thickness of the cup. We have separated the cup into three parts. After finding the volume enclosed by the outer function, we subtracted the volume enclosed by the inner function, which would give us the volume of the thickness of the cup. This was calculated using the washer method. Then, to ultimately find the volume of the empty cup, we subtracted the volume found by the washer method, which is the thickness of the cup, from the volume found from the outer radius. This will give us the volume inside the cup, resulting in about 395.608 centimeters squared.
Now moving on to the cross-section method. The cross-section method uses the area of the slices of shapes when the object is perpendicularly cut and adds them all up. The formula used is here. The cup we were assigned to had circular cross-section, so for the AX, the circle area equation pi r squared was used. A and B would be 0.2 to 9.6 for the first region, and for the second region, 9.6 to 10.7. The radius length for the first region was the blue line of the graph here, so the integral above was used for the first region, resulting in 375. The green line was the radius length for the second region, so with the green line as R, the integral above was used, resulting in around 21. Added together, the total was 395.608.
Now it works.